Hello lovelies, in this video the brilliant Mr. B is going to be looking at linear sequences for your GCSE maths. Now, linear sequences is a skill that comes up on its own and as part of other sequences, so it's really important that you're secure in being able to do all of these questions. What I want you to do is look at the question as it's on screen, pause the video and then try and have a go at it yourself. Once you finish this video, if you want to try loads more questions, then they're all over for you on my website, link in the description.
Okay, we're going to have a look at linear sequences. Now, you might be asked a variety of questions about linear sequences, and the key is to look at the gaps in between the numbers. So, for example, in question 1, I'm going to ignore the negatives for now, we have 7, 21, 35, 49, and 63. So, you've got to think, what do I add to 7 to get up to 21? Now, a good way to do this might be a column subtraction. So, we want to get to 21. We're starting at 7, so a takeaway will be the way to figure out the gap in between. Now, we're going to have to borrow 1 to start, so 11, takeaway 7 would be 4, and then we've got the 1 that was left over, so we've got 14. So between 7 and 21, there is a gap of 14. Now, let's check the next one. Now, you might just assume that the entire sequence is 14, and it is, but you do want to check because sometimes you might get a sequence that doesn't increase by the same amount each time, and they're called, for example, quadratic sequences or geometric sequences. So you want to check it's actually a linear sequence. So I want to get to 35. I'm starting at 21, so let's do a takeaway. So 5 takeaway 1 is 4, and 3 takeaway 2 is 1. So that's 14 as well. So I'm fairly confident now that this is going to be a linear sequence, and it's going to be going up by 14 every single time. Now, we're being asked by how much is the sequence changing. And remember at the start I said, oh, we'll forget about the negative numbers for now. Well, it's not 7 and 21, it's -7 and -21. So we're not going up by 14, we're going down by 14. So each one is going to be takeaway 14. So by how much the sequence changing, we are taking away 14. So let's look at question 2 now. We have 11, 18, 25, 32, and 39. Now, between 11 and 18, 11 plus 7 would be 18. And then let's try 18 plus 7 to see it's a linear sequence. 18 plus 7 would be 25. So again, we're going to be fairly certain now it's a linear sequence. Let's just check the next one. 25 plus 7 is 32. So we know that that's plus 7 as well. So this is definitely going to be a linear sequence going up by 7 each time. Everything's a positive number. So we're adding 7 each time. Now, as well as being asked by how much sequence is changing, you might be asked to find specific missing terms in a sequence. However, it's exactly the same method. So we'll look at our sequence, 7, 13, 19, 25. We're going to think about what's going up by each time. So 7 plus 6 would be 13. And we're going to check it's plus 6 for all of them. So 13 plus 6 is 19, and 19 plus 6 is 25. So again, after a check 2 or 3, we're confident it's a linear sequence and it's going up by the same amount each time. That means to get from 25 to the next number, we are also going to be adding on 6. And 25 plus 6 is 31. So the missing term is 31. Moving on to question 2. We've got negative numbers again, but we'll ignore the negative numbers to start with. So we have 13, 19, 25, and 31. So from 13 to 19, again, that's going to be another plus 6 question. And then from 19 to 25, it's going to be another plus 6. And then from 25 to 31, that'll be another plus 6. We're just going to remember, it's not actually plus 6. We have negative numbers in a negative number sequence. It'll be take away 6 instead. So the next step, we'll be taking away another 6. So again, if we ignore the negative numbers, 31 plus 6 would be 37. The negative numbers would actually be a negative 37. Negative 31, take away 6 is negative 37. But you know, it's the negative numbers, don't actually change the digits you're using. It's always going to be a 3 and a 7. The negative numbers just change the sign at the front. Moving on to question 5. Now, with this one, we've got quite a lot of gaps here. And we don't have two numbers next to each other, so it's very difficult to figure out where it's going up by each time. So I'm going to set a diagram like normal. So we're going to go from 5 to this question mark, and from that question mark to that question mark, and that question mark to 7. And you'll see that that is 3 jumps. Now, all 3 jumps all together, we're going from 5 to 11, so that would be plus 6. So 3 jumps is plus 6. So if I divide that by 3 and share that plus 6 between the 3 increases we have, it'll be plus 2, and plus 2. So now we know it's going up by 2 each time, we can write out the whole sequence. So we'd have 5 plus 2 is 7, plus 2 is 9, plus 2 is 11, and plus 2 is 13. And then we had some of those already in the questions. I'm just going to make clear which ones are the answers. So 7 was a missing number, 9 was a missing number, and 13 was a missing number. The biggest mistake that students will make with questions like this is they'll assume which question it is and get them mixed up. So, for example, when they're finding a missing term, they might just write this is a plus 6 sequence rather than writing that the missing term is 31. By changing, they might actually continue the sequence and so getting the different bits and pieces mixed up. So it's very important to carefully read exactly which thing the question is asking for. Moving on to the medium questions, we're now describing sequences using algebra. So the first sequence is the 2n plus 6 sequence. So let's look at what 2n plus 6 actually means as a sequence. Now, what we're going to do is swap the n with different numbers. And for the first 5 terms, we're going to swap n with 1, 2, 3, 4, and 5. So let's look at how this works. Now we're going to do a substitution. So in 2n plus 6, if n is 1, that would be 2 1s plus 6. So 2 times 1 is 2, and plus 6 is 8. When n is 2, that would be 2 times 2 plus 6. So 2 times 2 is 4, and plus 6 is 10. So essentially what we're doing, we're remembering the algebra rules. We've got a number and a letter next to each other. It's a multiplication. We don't write multiplications in algebra. So we're multiplying the 2 by all the numbers from 1 to 5. So we do 2 times 3 plus 6, 2 times 4 plus 6, and 2 times 5 plus 6. And all the answers are going to give us all the different terms of the sequence. So 2 times 3 is 6, plus 6 is 12. 2 times 4 is 8, plus 6 is 14. And if you look at the sequence, 8, 10, 12, 14, it's going up by 2 each time, so the last one must be 16. And rather than writing out that sequence, it's faster just to write 2n plus 6. So now I can go over to the question and just write in these numbers, and these are the first 5 terms. Now, you could draw a diagram like that for every single question, problem. On an exam, you might be asked 1 or 2 questions like this, so spending the time on the diagram would actually be quite a good idea, but I don't have the space for it, and I'm going to try and show you a shortcut. So looking at 8, 10, 12, 14, 16, I'm going to point out first that in the sequence name, 2n plus 6, we've got a 2, and we've got a plus 6. And 2 plus 6 is 8. So if you add together the numbers in the name of the sequence, you will get the first term of the sequence. The next thing I want to point out is this sequence is going up by 2, and you actually have a 2 in the sequence name. It's 2n plus 6. So the number on the n term is the same as what we're going up by every single time. So let's try this with question 2. So firstly, we've got numbers in the sequence. We've got a 4, and we've got a take away 7. So 4 take away 7 is negative 3. And that will be the first term of the sequence. The next thing we're going to look at is that there is a 4 on the n. So this is going to be a plus 4 sequence. So negative 3 plus 4 is 1. 1 plus 4 is 5, 5 plus 4 is 9, and 9 plus 4 is 13. We can use the kind of how the name is set out, where the numbers are positioned, to work out the entire sequence without making a large diagram. So let's do the same thing with question 3. We've got a -6 and a +2. So -6 plus 2 is 4. So this sequence is going to start off at 4. Then looking at the number on the n, it's a -6, so we're going to be going down by 6 each time. So 4 take away 6 is -2. -2 take away 6 is 8. -8 take away 6 is -14. And -14 take away 6 is -20. Now, you might not just be asked to find the first 5 terms, you might be asked to find specific terms. For example, in question 4, we want to find the 20th term. Now, we don't need to make a huge list of 20 numbers here. We can go straight to the 20th term. Now, use the same method, we use question 1 with a little table. And all we're going to do is swap n with 20. So that would read 2 times 20, take away 8. We use big-mass rules to do the multiplication first. 2 times 20 is 40, and then 48 is 32. Let's do the same thing with question 5 with the 35th term. That means we're swapping n with 35. N is always talking about what position of the sequence you're up to. So we have -2 times 35, and then we are adding 6. So 2 times 35 is 70, but it's a -2 times 35, so it'll be a -70 plus 6, and -70 plus 6 is going to give us -64. Again, it's getting these mixed up. So for the first 5 terms, they might actually find the 5th term only. For the 20th term, they might mistakenly just write the first 5 terms. They might write the entire list, or they might even do something from the easy questions and just find out what the next term is, or say, oh, it's going down by 8 each time. So it's very important to read exactly what the questions are asking you, because there are multiple ways to ask these sort of questions. Moving on to the hard questions, what we're being asked to do now is to take a sequence written with numbers and to change it into a sequence written in algebra. An nth term is just a way of asking you to write the sequence using algebra. Now, like most of these questions, the first thing to do is figure out by how much the sequence is going up by each time. So in the first question, we have 7, 10, 13, 16, 19. It's going up by 3 each time. Now, there's a sequence that everyone knows goes up by 3 each time. The 3 times table goes up by 3 each time. And what we're going to do here is compare the 3 times table to the sequence that we have, because you can write the 3 times table by saying 3n. And the reason why that works, we'll just test this out to make sure it's true. If we have 3n, and we're going to swap n with 1, 2, 3, 4, and 5. Let's have a look at what happens. We'd have 3 times 1, 3 times 2, just swapping n with the number, 3 times 3, 3 times 4, and 3 times 5. That looks a lot like 3 times table. And we calculate these, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so on. So when we say 3n, that is the algebraic way of saying this is the 3 times table. Now, obviously, looking at question 1, we don't have the 3 times table. It doesn't start with 3, it starts with 7. The second term's not a 6, it's a 10. But what you might notice is, if you look at the green sequence, which is the 3 times table, and you look at the sequence in black, which is the one that we've got, you should see that going from 3n to our sequence, you have to add on 4 to each one. So 3 plus 4 is 7. 6 plus 4 is 10. 9 plus 4 is 13. 12 plus 4 is 16. 15 plus 4 is 19. So we're adding 4 to each part of the sequence. So we put plus 4 onto the end. The sequence 7, 10, 13, 16, 19 can be described by 3n plus 4. It's a 3 times table, but it's 4 bigger than the 3 times table at each point. So let's try this method with question 2. We have 0, 5, 10, 15, 20. Now this sequence is going up by 5 each time. So we're going to start off by writing down the 5 times table to compare. And the 5 times table will be described by saying 5n. Now obviously we don't have the 5 times table, so what do we do? The 5 times table to get to our sequence. So we look at the first number. We're going from 5 to 0. That would be taking away 5. Let's check that works with the rest of the sequence, because if it's not a linear sequence, this won't work. So 10 take away 5 is 5. 15 take away 5 is 10. 20 take away 5 is 15, and 25 take away 5 is 20. So this is actually working. So we'll put the take away 5 on the end of the algebra. So the nth term is 5n take away 5. Now let's take a look at question 3. So we have 8, 18, 28. This is going up by 10 each time. So we're going to start off with the 10 times table to compare. And if we're comparing with the 10 times table, then our nth term would start off with 10n. So going from the 10 times table to our sequence, it looks like we're taking away 2 each time. From 10 to 8, we're taking away 2. From 20 to 18, we're taking away 2. So we're going to add take away 2 to the end. The nth term is 10n take away 2. Now, question 4, we can see some negative numbers, but it's going to be exactly the same method. So nth term, we've got 1, minus 2, minus 5, minus 8, minus 11. This is going down by 3 each time. So if it's going down by 3, we're going to write the negative 3 times table to compare. It's very important to put the negative numbers on, or you will get the wrong answers. Now it's a negative 3 times table. We're going to write negative 3n. And now the same method as before. We're going to start off with negative 3n. We're going to move to our sequence and look at what we have to add or take away. So from negative 3 to 1, we must have to add 4. But I'll check with the rest. So negative 6 plus 4 will be negative 2. Negative 9 plus 4 will be negative 5. So it looks like we are adding 4 each time. The nth term will be negative 3n plus 4. So we have 2, negative 2, negative 6, negative 10, negative 14. It looks like it's going down by 4 each time. So I'm going to write down the negative 4 times table, just the 4 times table, but negative numbers. So that would be negative 4n. We'll have a look at what we need to add or subtract to get to our sequence. So from negative 4 to 2, we must be adding 6. We can test out the other items in the sequence. So negative 8 plus 6 is negative 2. Negative 12 plus 6 is negative 6. This all seems to work. So we've got our final answer. Now, all of these answers are mathematically correct, and they will give you full marks in any exam. Answers and mark schemes that might confuse you. So you might see negative 3n plus 4 written like this. And what's happened is the 4 and the negative 3n have been swapped around. Now, the reason why this is done is because positive numbers don't actually need the positive sign on. If it's at the end, like the positive 4 is in the original way it was written, you need the positive in there to show that it's positive. But if you've got a positive number at the start of an expression, you don't need to write the plus at the start. We just assume it's positive. And what this does is, it means we're using one less character to write down the sequence. So rather than using 5 characters, a takeaway, a 3, and then a plus and a 4, now we're using 4 characters because we didn't need to write down the plus sign. We've got the 4, the minus, the 3, and the n. And you'll see the same thing with the final question with the whole number and the nth term round. It means exactly the same thing. It will get you the same answers. It will get you the same number of marks in an exam. But it's useful just to know what that means, just in case you're given that as an answer and then you've written it the other way around and you feel like you might have made a mistake and you haven't. You get full marks for both versions.
Ouch! This is why in some videos I have unexplained scratches.